Geometry, geometry, geometry gives us all our shapes, you see. Well, can't you see? Circles, squares, prisms, spheres, shapes that look like rabbit's ears. The shapes of straights and shapes of plates. Naming, using all those shapes. Yes, all those shapes. Circles, squares, polygons, and all the shapes you've ever drawn.
Circles, squares, polygons, all the shapes you've ever drawn. Ovals, cubes, prisms, spheres, shapes that look like rabbit's ears. Hexagon and octagon and pentagon, all be gone. Pyramids here, squares over there, all the shapes that I can bear.
Geometry, geometry, geometry gives us all our shapes, you see. Well, can't you see?
Well, welcome back, geometry students. Here we are with 1.2 from our Big Ideas lessons. And in this lesson, it says that we are measuring and constructing segments. And actually, the funny thing is that we're not going to be doing so much of that on this video. We're actually going to do some more of that in class. But on this video, we're going to spend more of our time looking at just, again, vocabulary. There's some new vocabulary we have to look at. And also just really what the segment addition postulate, this third one here at the bottom, really is. We'll look at what the ruler postulate is, we'll look at some of that, but really we'll spend more time looking at segment addition in this lesson. All right, before we get into that, let's do a little quick cartoon of our day. So kind of going along with the becoming football season, here we go. And these two guys installed the uprights upside down. The goalpost is upside down. He's right, we screwed up. We're looking at their plans. That's a funny one. I laughed when I saw that one. All right, so here we go with our lesson here. Looking at page 9 in your notes. You have that, page 9 from 1.2, the ruler postulate. So in this one, let's look at what it says here for the ruler postulate. Now you have it down here for ruler postulate, but actually a couple words here are postulate and axiom that are on your vocabulary. So you want to write those down. It says in geometry, a rule that is accepted without proof is called a postulate or an axiom. So really these two words have the same definition. They mean pretty much the same thing. And so when we say postulate, we could also be saying this, an axiom, or axiom is a postulate. So you want to copy that down right there. So that a postulate or axiom, you can just have that for both of them, is a rule that is accepted without proof. So the rule that can be proved is called a theorem. So a theorem is a little bit different. We're going to see theorem as well, but that's a rule that can be proved. So if we can prove it, if we have to do something to prove it, that's going to be then a theorem. So, but a postulate is just something that we just accept without any proof. And so in this postulate 1.1 ruler postulate, you can see it says the points on a line can be matched 1 to 1 with the real numbers, the real number that corresponds to a point that is the coordinate of the point. And so then we have a line here with A and B. The names of the points are A and B. Here are the coordinates. If we're looking at a coordinate plane, the x1 and the x2, because it's a horizontal line, we would want to be looking then at the x numbers here, because the y numbers would actually be the same number. The x numbers would be different. And so it says the distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. So that's something to consider here, is that if we wanted to find the distance of this from a coordinate plane, we're going to want to look at the x numbers because it is a horizontal line. We want to take the difference of these numbers, so subtract these x numbers from the x coordinates, but then it's got to be the absolute value of that. So you remember, absolute value just always means it's going to be positive, and that's very key here when we're talking about distance, because distance always has to be positive. Of course, it wouldn't make any sense if distance was negative. You're not going to travel from home to school and travel in a negative distance. You always will be traveling in a positive distance. So we're going to subtract the numbers here from one point to the other, but we're going to always make sure it's the absolute value, which means it will always be positive in the end. All right, still on page 9, you have the word construction in your vocabulary. And you can just write this down for construction. Construction is a geometric drawing that uses a limited set of tools, usually a compass and a straight edge. So you can just copy that down right here for the vocabulary on a construction. Now, we're not going to do any constructions on this video, but we will be doing constructions throughout the year, especially first semester. We do more constructions then, and we'll be doing those in class. Those will be class activities for the constructions. Our core concept here on congruent segments. Now, the word congruent, again, when it's in the core concept, you don't have to write this down on the vocabulary because the definition is already here for you. Just kind of highlight congruent segments here, as this is a vocabulary word, and so here is the definition. And it's basically line segments that have the same length are called the congruent segments. And you can just highlight that there, right there on your notes on page 10. But the word congruent, this word right here, is going to be a common word we're going to use here in geometry. It simply means the same thing. It means equal to. So congruent always means the same or equal to. And so we're going to talk about congruent segments, congruent angles, a whole lots of different things are going to be congruent. And so that's just going to mean they're going to be equal segments. They're going to have the same length. They're going to be equal to each other. And so we can see it down here, a different way of writing this. The length of AB is equal to the length of CD, this segment here. And so you can say that segment AB is congruent to segment CD. That's what we're saying here. And the symbol, here's something to consider right here. This symbol, you may want to circle that as well. That symbol means congruent to. It's an equal sign with a little squiggly above it. So that symbol right there is like a similar with an equal to. So this little squiggly usually means similar to in math, and then it's on top of an equal. When we see that symbol, we're going to always see the word is congruent. That means congruent. So we can say lengths are equal, but segments are congruent. So that means that the numbers of these will equal, this whatever number this would be, the distance, the length of that would be actually a number. And so the numbers would be equal, but we could say just the very fact that the segments are going to be congruent. Notice that when we don't put the little line there, that's talking about the actual length of it, which would be a number. But when we do put the line here, that's just talking about segment AB. And we're told that they're congruent. Also, one other thing that you want to notice here are these little marks right here. Those marks are also congruent marks. They mean congruent to as well. So when we see those little marks here, that tells us that this is congruent to this one because they both have exactly the same mark. If there's more than one mark, if you might see one here and a two here, two marks, like a little two mark like that, then you wouldn't be able to say those are congruent to. But a 2 with another 2 on some other segment, a segment going through this and segment going through this one, that we could say is congruent to because they both have the same congruent marks. So it's not meaning that you're only ever going to see one. You might see it with 2. You might see 3 little marks on your segment showing there's a third one that's congruent to something else. So that's very important that you get this right now because we're going to use it a lot. Okay, so the first problem that we're going to really get into doing here is one like this, where we're going to be plotting points on a coordinate plane. They're going to give us 4 points here. We're going to connect 2 of them together at a time. So it wants us to connect J and K and make a segment out of that, and L and M and make a segment out of that. And it wants us to determine whether they're congruent. So we need to figure out, are their lengths equal? If the lengths are equal, then we know they're congruent. So as we do that, you can see here's what it would look like. Now you don't need to do any of this, just watch this one because we're going to do some of these on our own. So they plotted the 4 points, they connected J to K, so that made a horizontal line, and then L to M made a vertical line. So that we would need to figure out, okay, what is the distance between J and K? Now I know on a coordinate plane, you can simply just count the boxes if it's that simple. So you can say 1, 2, 3, 4, 5, and that'd be fine. You could also do what we said before is, since this is a horizontal line, you could look at these X numbers, subtract them, take the difference, and then the absolute value. That's what it's showing you here. They're going to say, okay, well, 2 minus negative 3, and then that would be actually 5, and the absolute value of 5 is 5. You could have done that the other way as well. You could have said negative 3 minus 2. That would give you a negative 5, but the absolute value of negative 5 is also 5. Now I know simply, like I said, we can just count and see that it's 5 really. On this one, you can see now you could do the same thing. You can count up or down and you can get the number there. Or if you needed to use the numbers and subtract them, you're going to work with the y numbers this time because it is a vertical line. So you'd be working with these numbers, 3 minus -2 or -2 minus 3, either way. It's going to be 5 again, so yes, these are congruent. We would say they're both 5, so since their lengths are equal, we can say then that the segments are congruent. So you can make a little statement out of that right here. Here's your answer, is the statement that segment JK is congruent, using that symbol, to segment LM. All right, let's go ahead and try some on our extra practice. So go to your extra practice on page 11, and this is 1 through 3. So what I want you to do here is you can do one at a time, and then I'll pause the video and then see the answer. But I want you to try this on your own. You can go ahead and plot these points, draw your coordinate plane, kind of like right down the middle, right across the middle. That should be enough. Plot A, B, C, and D, and you're going to connect A and B together for a segment and connect C and D together for another segment. And you want to determine whether those are congruent segments. Now I know on these ones, since they are probably going to be horizontal or vertical lines, you're going to be okay just by probably counting the boxes to see what the segment length is, and that's fine. So go ahead and try that for number 1, and then you can play the video again to check that answer. Okay, hopefully you finished number 1. Let's check number 1 before you go on to these other 2 problems. So let's check and see if you did number 1 correct. So here's what you should have had. Now, they actually didn't connect the dots. I would prefer if you would connect the dots here to make a segment, just so you can see the segments here. And you can see, well, this one is 1, 2, 3. That's the length of this. AB is 3. This one here is 1, 2, 3. So the length there is 3. So yes, they are congruent. Go on to number 2. Do the same thing. Plot these points. Connect A and B together. Connect C and D together. And then you can see, are those segments congruent? Okay, so hopefully you did that. Now let's check number 2 to see if you did this one correctly. So if we plot these points, we see, okay, A, 4, 0. We're down over here on the x-axis. B, 4, 3. You know, we're going to be up here in this first quadrant. There's that segment, and that distance is 3. We can just count it and see 3. We would be subtracting the y numbers. You can see 3 minus 0 does equal 3. And then point C, we got -4 down in the third quadrant, and -4, 1 right up here. Also makes a vertical line. You can connect those, and that would be 1, 2, 3, 4, 5. So this one's 3, this one's 5, so no, it's not congruent there on that one. And then for number 3, go ahead and do that one. Plot those points again and see if that's congruent, and then go ahead and play it, and we'll check that. Okay, so you should have finished number 3. And let's just see where those points are. So A is in this second quadrant up here at -1, 5. B is in the first quadrant, 5, 5, and that goes across, stretches here, 1, 2, 3, 4, 5, 6. So that's 6 for that length. And then C is still in the first quadrant, D is in the fourth down here. It would be 1, 2, 3, 4, 5, 6 also, and there, yes, those are the same lengths, so that means that they are congruent. Okay, before we leave this, before the 2 that are congruent, number 1 and number 3, let's write a congruent statement down here. So we would just say on this one for number 1 that we would say segment AB is congruent. Let's use that congruent symbol to segment CD. So remember, this line segment here is just a line going across there, no arrows. And we'll do the same thing for number 3. We would say on this one as well that AB, segment AB, is congruent, using that congruent symbol to segment CD. Go ahead and put that down just right below your graphs. Okay, so back on page 9 with our vocabulary, we have the word between. Now I know that one seems like it's a little bit, you know what between means. So you don't need to put too much down here. You might want to just draw a line here. You can draw this, that this point B is between A and C. Points A and C, and obviously on this one it says point E is not between D and F because it's not on the line, so it's going to be on the line. So when 3 points are collinear, remember collinear was a word from last lesson, they all line up, they're on the same line. You can say that one point is between the other 2. So if three points here are lined up, then B is going to be, this middle point here is going to be between the other two. So you can go ahead and draw these two if you just want to draw those, or you can write down this definition if you just want to write the definition on the word between. Okay, so on page 10, there at the bottom it says segment addition postulate, and we'll spend pretty much the rest of the lesson on this segment addition postulate. You're just adding segments together to get a longer segment. So we have, again, that same thing where B is in between AC, so these are collinear points. And we're going to know, okay, AC stretches from all the way from the first point to the other end point, and then we could see that AC is made up of AB plus BC. So by adding AB together and BC together, you're going to make the AC segment. So it's just, that's all it is. So AB plus BC is equal to AC. So here's a couple, let's just watch these as you look at this. It says just find DF. Now DF would be the entire segment from D to F. It means you just have to add up the two smaller segments, so segment addition. DE plus EF will give you the DF segment, and so that's what it's showing you here. It's almost like kind of making a little bit of an equation out of this. And so you're just going to add 23 and 35, giving you 58. That would be what DF would equal. And this one says find GH. Well, GH is this little portion. You're told the entire segment is FH is 36. This part's 21. So again, it's kind of like I said, a little equation you're going to build here, where FH, the entire thing, will equal FG plus GH. Now you know FH is 36 and you know FG is 21, so you fill those in. And GH now is kind of like your variable. You can think of that like an X right there. Just subtract 21 and you found GH is 15. All right, let's go ahead and try a couple of. Okay, so back on our extra practice page 11:4 to 6 just says find VW. Find the segment VW. And it's not always going to be in the same place. VW is on this one is this part here. VW is this part here, and this time VW is the entire thing. So go ahead and pause the video and do 4, 5, and 6. Use the segment addition postulate to help you find out what is VW. What's the number for VW? Go ahead and pause it, and let's check our answers after that. Okay, so hopefully you finished 4 to 6. You got the answers for VW for each one. For number 4, we're going to make a little kind of equation on this one. So VW on this one is equal to 31 minus 8, because we can just subtract them. The whole thing minus 8 would give you VW. I mean, you can do, VU is equal to VW plus UV or WU. What I usually typically do, if I'm missing this little part, I'm going to take the whole long thing and subtract the one there I'm given, and that would give me my other segment. So that right there is just going to give us 23. For this one, we're going to be doing the same thing. 18, basically minus 6 will be what we have to do on this one. So, because these two would add up to give us 18. So 18 minus 6 would give us their VW. That's going to give us 12 for VW. On this one, we're just going to now add up these two. So VW is going to equal 45 plus the 30, and so that gives us a 75 for VW. Okay, so these are fairly simple to do. It's very easy when you're given the two segments here and you're finding the long one. You just got to add. But if you're given the long one and given one of the short ones and you have to find another short one, that's where you're going to be subtracting. The long one minus this little short one will give you what you're looking for. Okay, so here we'll pause for our joke of the day. So why did Cinderella get kicked off the soccer team? Well, because she ran away from the ball. That isn't good. Okay, let's just watch this one. We'll do one similar to this in a minute, but this one's just more like kind of a real life, situation where you might use this if you're traveling maybe across the country, and here it is. The cities are shown on this map. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. And so, you have, Tulsa's here in the middle, St. Louis is up here. You're trying to figure that out. You do know how far it is from Lubbock to Tulsa. That's 377 miles. And you also know how far from Lubbock to St. Louis is. That's 738 miles. So you're just going to use segment addition because these are collinear points. Tulsa's right along the same line from Lubbock to St. Louis. And so we can use segment addition here. And so you're just going to use that down here. You can see we make a little the equation out of it. They filled them in again. We're going to subtract 377 then with, like, from both sides, or you can just do 738 minus 377 to get your answer, and that would be 361 for the distance of TS, or from Tulsa to St. Louis. Okay, so problem 7 on our extra practice. I know this is the last one of the extra practice. We're going to do one more, and we're going to put that on page 10, that last one we're going to do in just a minute. But this one, let's do 7, and then we'll go on to one more before we finish up our lesson here. It says a bookstore and a movie theater are 6 kilometers apart along the same street, so that would mean they're on the same line. A florist is located between the bookstore and the theater on the same street. So again, it means they're all 3 collinear. They're on the same line. The florist is 2.5 kilometers from the theater. How far is it, or how far is the florist from the bookstore? So we want to, draw this out kind of as a segment, with 3 collinear points. And so we have the 3 things. We have our bookstore, the theater, and it says that the florist is in between somewhere. So we can use B for bookstore, T for theater, and F for the florist. Go ahead and we're going to draw a segment out. It'll look something like this. So you just need to make sure that your bookstore and your theater are on the ends, and the florist is somewhere in between. Doesn't really matter where it is in between. We're just going to put it in the middle somewhere. And let's go ahead and label down that the florist is 2.5 kilometers from the theater. So this little segment right here is 2.5. We know that. It also says that the bookstore and the theater are 6 kilometers apart. So from B to T, that whole long segment is 6 apart. And so now just to figure out what's the distance, or how far is it from the bookstore to the florist, or the florist to the bookstore, again, we're going to subtract 6 minus 2.5. That's all we have to do to figure that out. And so we're just doing BF is equal to 6 minus 2.5, and so that segment is 3.5 kilometers. That's how far it is from the florist to the bookstore. All right, so one last problem here. We're going to go to page 10. Just go back one page here. Okay, so this one I say notes at the bottom of page 10. So the very bottom of page 10, underneath that segment addition postulate. Go ahead and just draw this one out. Just draw a segment like this, endpoint P, endpoint C, A's in the middle. You can name them as well: Provo, Albuquerque, Carlsbad. That's what they stand for. It says again, the cities shown on the map are on a straight line. Find the distance from Albuquerque, New Mexico to Provo, Utah. And so you want to also number them as well. So the AC segment right here, Albuquerque to Carlsbad, is 231 miles. The entire segment from P to C we know is 680 miles. That's from Provo to Carlsbad. And we're trying to find out basically what PA is. So we can write this out. PA plus AC equals PC. So again, you're copying, you don't have to copy the map, of course, just copy the segment and the numbers, and then start writing this out. Let's go ahead and write it like this first, just to see it. PA plus AC is equal to PC. So these are the 2 segments that make up the longer segment of PC. Let's fill in what we know. We don't know PA, but we know AC and PC. So we're going to fill those in. So PA plus 231 is equal to 680. And all we have to do now to find PA is subtract 231 from both sides. And that means we just do 680 minus 231. That's kind of like what I said. You can just take the big segment, the whole long segment, and subtract out the smaller one you have or that you're given, and that will give you what you need or you're trying to find. And so now 680 minus 231, that will be 449. So PA from Provo to Albuquerque, that's 449 miles. All right, so that concludes our lesson here, 1.2. You ready to go on to the assignment? I'll see you on the next lesson.